what are the different type of the waves we use, like radio waves, microwaves, and infrared waves. Now, coming to the today's topic, we'll discuss different type of the network connectors. After that, we are going to start very important topic, that is OSI layer. What is the use of OSI layer, and what are the different layers we have in the OSI model, and what are the functionalities of each and every layer. Then let us start with network connectors. The connectors or the interface. The connectors or the interface for the communication between computers. If you want to connect any computer with another computer, we may use one connector. Okay, that is the meaning of this sentence. It is just like an interface between computer to computer and computers to network devices also. If you want to connect any computer device to any other computer devices like hub, switch, router. Like if you want to connect a computer to a hub or computer to a switch, computer to a bridge, computer to a router. Like if you want to connect your computer device to any networking related device also, we use connectors. Okay. So connector is an interface that is used to connect a computer to computer or computer to any other networking devices. We have different type of the networking related connectors. And let us see few of them and very frequently used networking connectors. In that, very frequently used one is RJ45 connector. Here, the name RJ45. RJ stands for registered jack. RJ stands for registered jack. The RJ45 connector is an 8-wire connector. So in the image also you can observe here. In the RJ45, we have 8 wires internal. Okay, 8-wire connector that is used to connect the devices majorly in the LAN, local area network. So already one of our sessions we covered what are the different type of the networks we have, like LAN, MAN, PAN, WAN. Okay, so this RJ45 is used in the LAN. These RJ45 connectors are mostly commonly used with Ethernet cables in the computer networks. Generally, for the LAN also, we use Ethernet cables. And if you observe this that if you observe this image, we have two different types of the RJ45 connectors. Those are RJ45 female connector and RJ45 male connector. By this image, you can understand how that will be. Okay. So male, just like you can observe pins here, and you may like holes here are J45 females. That is used to connect female and male to the required cables. Next, RJ11, registered jack 11. It is a common connector for plugging the telephone into the wall and plugging to the telephone into the handset also into the telephone. It uses a twisted pair cable. So in our last session, we covered what is twisted pair cable already. So RJ11 uses a twisted pair cable and a modular jack with 2 or 4 or 6 contacts. You can observe the images related to the RJ11. And in this RJ11 also, we have male and female connectors. Next, RJ12. So these all belongs to the same family, RJ11, RJ13, RJ14. and it is a same 6 slot connector. RJ12 also a 6 slot connector, and RJ12 has a 3 pair of copper strands allowing exchanging of information on 3 lines. On other standards allow exchanging only on 1 or 2 lines only, but RJ12 allows 3 lines. RJ12 allows the connectivity of telephone lines in companies, while RJ11 aimed at individuals. This is about RJ12 now. RJ12 is used for the connecting purpose in the companies, and RJ11 is used for the individual purpose. Next type of the connectors are Cat5 cable. In this, Cat5 means category, Cat5, category 5. Okay. So the category 5 is a network cable, consists of 4 twisted pairs of copper wire terminated by an RJ45 connector. See here, Cat5 cable consists of 4 twisted pair of copper wires and one RJ45 connector. Then it can be also known as Ethernet cable or LAN cable. This category 5 cable is used in home and you can use in the business networks. The speed of this Cat 5 is up to 100 Mbps. And let me tell you some more points about the category 5 cable. The maximum recommended length of the category 5 cable is 100 meters only. And this is very important point. The Cat5 cable has 8 different color wires. I will show you the image in the next slide. It has 8 different color wires and it has a specific wire order to follow to connect to a connector. Nothing but it maintains a 8 different colors and the order is also different. Every connector maintains some order. If you want to connect, you must follow that particular order. If the wires are in not in correct order or in the different order, the cable doesn't work. So there are 2 standards usually followed worldwide, and they are T568A and T568B category 5 cables. These standards follow specific color for the wires to be connected or crimped. Generally, the word we use crimped while working with in the lands. For that, we use some different crimping devices, and we use RJ45 jack for the crimp. This is the image related to T568A and T568B. Observe carefully. It has different color. 568A. First one is a green and white combination, and the second one is full green color, and the third one is orange and white combination, and so on. Fourth is full blue, and so on. So finally, it has a specific colors and specific order. And in the same way, if you observe 568B, it has again different colors and different orders. You compare this, every cable has a different color and a different order. Order is different, color is different. Next type of the connector is HDMI cable. Everyone knows it, everyone probably using in their day-to-day life. HDMI stands for high definition multimedia interface. By the name, you can get some idea about this. It is used for multimedia purpose, nothing but to transmit the videos and sounds with a good quality, HD high definition with good quality. So by the name, you can understand the importance of HDMI, high definition multimedia interface, a standard for simultaneously transmitting digital video and sound over a single cable. Before this, we had a different type of the cables called a 3P cable. One wire is for video, one wire is for audio, and so on. Nothing but one cable dedicatedly used for video, another cable is dedicatedly used for sound. But here we are using only single cable, and we are trying to transmitting high definition, best quality video and audio over a single cable. That is the purpose of HDMI. It was developed by consortium of electronics manufacturers and has been widely adopted by almost all televisions and all computer manufacturers. If you observe, if you recently purchase any television or any monitors, probably each and every company of the televisions and computer monitors have the HDMI facility. The HDMI connectors are available in three sizes. Those are standard HDMI, mini HDMI, and micro HDMI. The standard HDMI connector, that is also called Type A connector. Generally, people may use Type C, Type A, right? So the standard HDMI connector, that is also called Type A connector. It is the most widely used connector, Type A connector. I will show you the image. Now see this. This is a Type A connector. This is the standard one in HDMI. And next size is Type C connector. It is also called mini HDMI. And when compare the size of this mini HDMI with the standard HDMI, the mini HDMI size is 60% smaller than the standard HDMI. Third category is micro HDMI. This is also called Type D HDMI. And regarding to the sizes, this Type D micro HDMI is 72% smaller when compared to the standard HDMI or Type A HDMI. So this is about three different types of the HDMI cables regarding to their size. Next connector is OTG connector. No need to give the introduction about this, I hope, because probably all the people may are using this OTG connector in the day-to-day life. One interesting point we need to know is the full form for the OTG is on the go. The full form for the OTG is on the go. OTG connector or on the go connector. So it is a standardized specification that allows a device to read the data from a USB device. If you want to read the data from any USB device, then you can use OTG connector. Okay. You will need an OTG cable or OTG connector. For example, if you want to connect a pen drive to your mobile may not have USB port, right? But this OTG connector has USB port, and it has a facility that can be used for the mobile. So you can connect this end for the phone. Okay. And for this end, you can attach your pen drive. Like that, with help of the OTG connector, you can read the data from the USB device, where in this example, the USB device is pen drive, because pen drive is also USB based device. So with help of the OTG connector, we can read the data from the any USB device. Right? So already we covered this example. The easiest way to check whether your phone or tablet support the USB or not, you can go through the manual of that particular device. You will get the information related to the OTG support. So as of now, we covered three units, Unit 1, Unit 2, Unit 3, as part of the Block 1. Now, we are going to start Block 2. In the Block 2, we have four units, fifth unit, fourth unit, fifth unit, and sixth unit. So the major point or major topic in this Block 2 is OSI layers. What is OSI layer and what are the different functionality each and every layer has, and what is the use of OSI framework. We are going to cover all those points. First one is, what is OSI? What is the full form for the word OSI? OSI stands for Open Systems Interconnection. Open Systems Interconnection. By the word, you can understand that it is used to connect the systems. Okay, general meaning. And it has been developed by ISO. So this is the organization name. Don't confuse. OSI is the model name. ISO is the company name or organization name. The full form for the ISO is International Organization of Standardization. Okay, the order is might be different. ISO, but the meaning is International Organization of Standardization. Some people may say it in simply International Standardization Organization, but actually the name is International Organization for Standardization. And the OSI model was developed in the year of 1984, right? And it has seven layers. It has seven layers. We can say that OSI model is a seven-layer architecture where each and every layer has a unique functionalities to perform. Every layer has a specific functionalities to perform in the network. All these seven layers work collaboratively to transmit the data from source to destination or one person to another person across the globe. We have seven layers. Those are logically separated, and but they work collaboratively to transmit the data. So before going to start the OSI model, let me tell you some more points. Actually, what is the use of OSI model? What was the scenario before the OSI model in the network? So suppose if you observe before the OSI model, the scenario is every company maintains their own format to transmit the data. For example, IBM maintains their own format to transmit the data over the network. And coming to the Apple also, Apple maintains their own format, their own rules to establish the network. There is no any standardized rules to frame the network. That's why if anyone wants to communicate between the two different companies, it was very difficult because the underlying architecture of one company might be different from another company. So one company network may not communicate with the another company network at that time. So that's why the those problems identified in that system were overcome with the help of the OSI model. So with the help of the OSI model, this ISO gives some standardization, some framework. While creating any network, every company has to follow these rules. Then, with help of this standardization, any system can communicate with any other system. Any network can communicate with any other network. So, You can connect all the different type of the networks also with help of the internet. So that is the main intention of the OSI model. As I covered, OSI model is a layered approach. It has different layers. So this is the complete picture about the how many layers OSI model has and what are the names of those layers. We have 7 layers in the OSI model. We have 7 layers in the OSI model. Those are physical layer. First layer name is physical layer. Second layer name is data link layer. You must remember each and every point here. At least first point is you must remember the names of all layers. That is compulsory. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are the 7 layers. The physical layer is the first layer, that is also called layer 1, or in short, in the diagrams that might be represented with L1. L1 means layer 1. Layer 1 is physical layer. Suppose if I write L2, you must understand that L2 stands for layer 2, which is the second layer in the OSI, data link layer. Like that, we have layer 7, that is L7, application layer. Now, next point is the bottom 3 layers. The bottom 3 layers are network support layers. These are mainly used to work with networks. Network support layers. And upper 3 layers are user support layers. Mainly these are developed for the user purpose. User may interact with this and that may be used for encoding techniques and for identifying the users and so on. So that's why those 3 are called user support layers. And generally for these top 3 layers, user support layers, we use different softwares to implement the different functionalities. That's why these 3 layers are also called software layers. Remember each and every point. And the bottom 3 layers are called hardware layers because these are work with different hardware uh, devices like hubs, routers, etc. That's why these are called hardware layers. Top 3 layers, software layers, and those are user support layers. Bottom 3 layers are network support layers. They are also called hardware layers. Coming to the transport layer, it acts as an interface between software layers and hardware layers. This is also called heart of OSI. So this is a basic information about the OSI layers. Now let us start our discussion about functionalities of each and every individual layer. Let us start with layer 1, L1, that is physical layer. The main functionality of the physical layer is to transmit individual bits from one node to another node. Okay. So if you want to transmit any data in the form of the bits in the physical layer, the data is transmitted in the form of the bits. and the data is transmitted in the form of the bits from one node to another node in the physical layer. So that is the major functionality of the physical layer. It is the lowest layer of the OSI model. Yes, we just now seen that image. That is the lowest layer. It establishes, maintains, and deactivates the physical connections. Okay, what are the physical connection you are maintaining in your networking? All the physical connections maintained by physical layer only. It specifies mechanical, electrical, and procedural network interface specifications. All the mechanical and electrical and procedural network interfaces specifications deals with physical layer only. Then this is a very important point. What are the functions of the physical layer? Line configuration, data transmission, topology, and signals. If you observe this, already we covered all these topics. See, line configuration, data transmission modes, topology and types of the topologies. All are we covered already as an individual topics. Now, if you understand those topics, you can easily understand the functions of the physical layer. Then first one is the line configuration. Very simple. The line configuration means how the devices are connected. How two or more devices are connected to the network. How those are connected physically. That is the meaning of line configuration. In our yesterday session, we covered, I think, yesterday or day before yesterday, we have two types of the configurations. Those are point-to-point configuration and multi-point configuration. We covered that already. So point-to-point configuration means the complete link is shared by only two devices. And in multi-point configuration, same link can be shared more than two devices. So that is about line configuration. So this is the functionality of the physical layer. Line configuration is functionality of the physical layer. Then data transmission, nothing but data transmission mode. In one of our session, already we covered what are the different types of the transmission modes we have, like simplex, half duplex, and full duplex. Simplex means so always the data can be flow from one direction only, unidirectional. It has half duplex. It has bidirection, but at a time only the data can be transmitted by using only single direction. Even though it supports bidirection, at a time it supports only single direction. Third category is full duplex. So it is a bidirectional method, and at the same time, simultaneously, we can transmit the data in the bidirection. So we covered that already. So data transmission is also responsibility of the physical layer. Topology. So yesterday itself we covered what is topology, what are the different type of the topologies. All these are can be done in the physical layer only. Topology is nothing but how we are organizing or arranging the cables or devices. Signals, it determines the type of the signal used for the transmitting the information. See this image. When working in the real time, the physical layer receive the data from the upper layer of physical layer. Nothing but L2 layer. What is the L2 layer? We have seen just now, no? Data link layer. So it receives the data from the data link layer from the source side. Let us say that is the source. This is the destination. From the source side, it takes the data from the upper layer of this one. What is the L2? That is data link layer. So it receives the data from the data link layer and that will be submitted to the physical layer. This box is a physical layer. Data is converted into the bits and that will be sent to the destination and that will be transmitted to any transmission media, whatever we are using between these two devices. At the destination side or at the receiver side, the physical layer will receive this data in the form of the binary digits or bits that will be submitted for the data link layer. So this is about how physical layer works. Next one, data link layer. This layer is responsible for error-free transfer of data frames. Very important point. Error-free transfer of data frames. Data frame is nothing but in the OSI model at each and every layer, the data is maintained in different forms. In the data link layer, the data is maintained in the form of data frame. I will show the structure of the data frame in the next slides. So data link layer defines the format of the data on the network. Okay. Then it provides a reliable and efficient communication between two or more devices. The main responsible for the unique identification of each device that resides on the local network. So the main responsibility of the data link layer is to finding the unique identification of the each device. Actually, that is called MAC address. Okay. If you have the idea, just you can find the MAC address with help of the command line argument. You will get the MAC ID. Every computer has a MAC ID. So that is very unique ID. With help of that, we can identify the every device in the network. Okay, every device has its own MAC address. How we have a unique number like Aadhaar number for the unique identification of the citizens of India. In the same way, every device that might be a laptop or any network devices has a MAC address that is used to identify a device uniquely. So that is the main responsibility of the data link layer. Again, this is also very important regarding to the data link layer. In the data link layer, we have two sublayers again. The two sublayers, the data link layer has LLC and covered the MAC address. Then what is LLC? What is MAC? LLC stands for Logical Link Control Layer. LLC, Logical Link Controller. Okay, Logical Link Control Layer. It is responsible for transferring the packets to the network layer of the receiver. Okay. And what is packet? We'll cover later on. That is our data format in the network layer. LLC identifies the address of the network layer protocol from the header. What is header is nothing but that is one top of the one part of the data. I will show you that. It also provides flow control. LLC responsibility is flow control. How much data can be sent? What is the speed of that transmission? That will be controlled by the LLC. Next one is MAC, Media Access Control. LLC means Logical Link Control. MAC, Media Access Control. A media access control layer is a link between logical link control layer and a network's physical layer. It is used for transmitting the packets over the network. With the help of the MAC only, a pack can be delivered at the correct device. Because with the help of the MAC, we can identify each and every device uniquely, as we covered just now. Coming to the functionalities of the data link layer, very important functionality of the data link layer is framing. So the data link layer that translates the physical layers related raw bit streams into a different form of the data. Those are called frames. The data link layer adds the header and trailer to the frame. I will show that image. The header which is added to the frame contains the hardware destination and source address. Now you can observe. So while working with the data link layer, the data is formed in the form of the framing. And for every frame, yeah, see this? This is the frame structure. Okay. This is one frame and this is another frame. Frame has header, trailer, and payload. Header consists of a hardware address. Just now we covered. The header, which is added to the frame, contains hardware, destination, and source address. From where you are sending to where you are sending the data. Source address and destination address. And this address is a hardware address, physical address. And frame header, just now we covered, it contains source and destination address of the frame, where to where the data frame has to be sent. Payload field, it contains the message to be delivered. With help of the frame header, we can identify from to in simple words, from address to address. Payload means what is the body of the message, what is the message you want to send. That is payload field. Next one is a trailer. Third part in the frame is trailer. It contains the error detection and error correction bits. Okay. Because while transmitting the data, we need to find whether that might have some errors. We need to detect that and we need to correct that. For that, we use a trailer. Next. Functionalities of a data link layer. We covered first functionality, that is framing. And we have seen the frame image also, right? The next functionality is physical addressing. The data link layer adds a header to the frame, just we covered already, that contains the destination address, not only destination, source address also we covered. The frame is transmitted to the destination address mentioned in the header. So what is the address you mentioned in the header within the frame? To that particular address, that frame will be delivered. Next functionality is flow control. Flow control is the main functionality of the data link layer. It is a technique through which constant data rate is maintained. This is the important part. Constant data rate is maintained on both the sides so that no data get corrupted. Because, for example, we have source and destination, or sender and receiver. Sender is sending the data with great speed, but receiver is not able to receive with the same speed. In such cases, data get corrupted. Okay, there is no meaning if we implemented the network like that. Sometimes sender speed may be low, but receiver speed is very fast. In that, receiver has to wait more time to receive the data from the sender. So here the point is to overcome these two problems, we need to maintain a constant speed, constant data rate between the sender and receiver. So this is the responsibility of the data link layer. Data link layer will take care about this flow control. It ensures that transmitting station such as a server with higher processing speed doesn't exceed the receiving station with a lower processing speed. So very simple. Here the data link layer with help of the flow control is trying to maintain the same speed for the server and clients. Okay. Next functionality is error control. Okay. Error control. Error control is achieved by adding calculated value, CRC. Very important keyword in the networking terminology. CRC, cyclic redundancy check. This CRC is placed to the data link layer's trailer. Just now we covered what is trailer and what is the image related to the frame. Na? In the frame we have header, payload, and trailer. So this CRC is placed to the data link layer's trailer, nothing but to the frame. Within the frame we have the trailer, which is added to the message frame before it is sent to the physical layer. If any error seems to occur, then the receiver sends the acknowledgement for the retransmission of corrupted frames. So with help of the CRC, we are going to identify the errors. If any errors occurs, the receiver sends the acknowledgement with help of this error control mechanism. And when the sender receives the error related acknowledgement, the sender try to resend the same data again. So this is the important related to error control. Access control. Suppose there is one resource, but two sources are competing to use that resource. We have only one resource, but two processes are, let me tell you in the networking related terminology, two devices are trying to access that. But which should be accessed, which should be in the waiting state. For that, we use access control mechanism. The access is controlled in simple words. So this is also one of the responsibility or functionalities of the data link layer. Now see this image. Observe this for a moment. Just assume that this is the sender and this is the receiver. So we are discussing about the data link layer. Na? We discussed all the functionalities of the data link layer like framing, flow control, error control, access control, right? And it receives the data from the network layer at the sender side. It receives the data from the network layer and it provides all the functionalities what we covered just now. It sends the data to the physical layer, which is useful to send the data to the receiver. And this is about sender side. At the receiver side, and coming to the data link layer, the data link layer will receive the data from the physical layer at the receiver side, and that will be sent to the network layer again. The network layer, L3, layer 3, network layer, last layer in the hardware supported layers. Now, it is a layer 3 that manages device addressing, tracks the location of the devices on the network. So in the previous case also we discussed one addressing that is called physical addressing, MAC address of the device. Every device has a unique address that is MAC device. But here we are using the same word again addressing. This is logical address actually. Okay. A network layer determines the best path to move the data from source to destination based on the network conditions, the priority of the service, and other factors. So whenever you are trying to sending any data from one system to another system through the network, the network layer responsibility is it is going to identify all the available paths and it returns which path is most suitable. So after selecting that path, the data can be sent with that particular path only. Then see the functions of the network layer: internetworking, addressing, and internetworking is the main responsibility of the network layer. It provides logical connection between different devices. This is the important part. Okay, in the previous case, that is in the data link layer, that is a physical connection. It is a logical connection between the devices. Addressing a network layer adds the source and destination address to the header of the frame. Addressing is used to identify the device on the internet. So if you want to identify any device that is connected to the internet, generally we use IP address. Okay, with the help of the IP address, we can identify that if it is connected to the internet or network simply. Routing and packetizing. Routing is the major component of the network layer and it determines the best optimal path out of the multiple paths from the source to destination. If you want to send any data from source to destination when you have multiple paths, in that best path is selected by the routing only, by the router only, where router is a hardware component and it has software component also. But routing is the process of selecting the best optimal method with the help of the routing. Packetizing, a network layer receives the packets from the upper layer and converts them into the packets. So coming to the network layer, the data is transferred from one device to another device in the form of the packets. You must remember this. Okay. In the physical layer, rabbits, network layer, frames, data link layer, frames, network layer, packets. So this is the different forms of the data while it is in the different layers. Now see this image. So from the above layer of a network layer, that is transport layer, from the transport layer, it receives the data and it creates the packets and it is header to the packet. This is the packet. And the packets will be delivered to the data link layer. Okay. Then again, a data link layer uh, uses its own functionalities and send the data to the physical layer. Okay. Then at the receiver side, the data is received by the physical layer and sent to the data link layer. And then the data link layer will send the data to the network layer. In the network layer, the data is in the form of the packets. Header is maintained. Header is used to maintain the addresses of the devices. And after performing the different uh, functions by the network layer, the data will be submitted to the next layer, that is L4 layer, transport layer. Then fourth category, that is transport layer. By the name, you can understand that. And one more important point, as of now, we covered three layers, three bottom layers, hardware layers. Okay. Now, transport layer, as we covered, this is the heart of the OSI, and it acts as an interface between uh, software layers and hardware layers, right? The transport layer is a fourth layer, ensures that messages are transmitted in the order in which they are sent, and there is no duplication of the data. A very direct sentence, you can understand it easily. Whenever you're trying to sending the data, the responsibility of the transport layer is it is trying to ensure that the messages are sending in the same order in which order the sender sent it, and the duplicate data should not be exist in the data. The main responsibility of the transport layer is to transfer the data completely. It receives the data from the upper layer and converts them into the smaller units known as segments. So this is important point. The data form in the transport layer is segments. The data is maintained in the form of segments. How can you define the word segments? It receives the data from the upper layer and converts them into the smaller units. Those smaller units are called segments. This layer can be termed as an end-to-end layer as it provides a point-to-point connection between source to destination and deliver the data reliably. That's why it is also called transport layer. The two important protocols we used in the transport layer are TCP, UDP. TCP stands for Transmission Control Protocol and UDP transfer User Datagram Protocol. TCP, UDP, User Datagram Protocol. Now, the major difference between these two protocols is TCP is wired one, wired protocol, and where UDP is a wireless protocol. Okay. So coming to the TCP, the points are it is a standard protocol that allows the systems to communicate over the internet. It establishes and maintains a connection between the hosts. When data is sent over the TCP connection, then the TCP protocol provides data into smaller units called as segments. As now we covered, the data is maintained in the form of segments. Each segment travels over the internet using multiple routes and they arrive in different orders at the destination. So the transmission control protocol reorders the packets to deliver in the correct order. So that is the responsibility of the TCP. It receives the data at the receiver side in different order, and before delivering to the related device, the data must be reordered. So this is the work should be done by TCP. Then UDP, User Datagram Protocol, is a transport layer protocol. It is unreliable transport protocol. And in this case, receiver doesn't send any acknowledgement when the packet is delivered. So the sender doesn't wait for any acknowledgement. Therefore, this makes a protocol unreliable. So this is somewhat unreliable. Then functions of the transport layer, service point addressing. Computers run several programs simultaneously. Due to this reason, the transmission of data from source to destination not only from one computer to another computer, but also from one process to another process. So the meaning of this statement is, for example, I'm using different applications at this moment. I'm using Zoom application, PowerPoint application, And let us assume that I'm using different app in the browser. So if I sent any request from the Zoom, let us say, the response must be delivered to the my computer. That is point one. And within my computer, that must be delivered to the Zoom application because I'm using multiple application. I'm using Zoom application, PowerPoint, and Microsoft Edge also running simultaneously.